In this video, I'm going to be looking at connected gas containers, and it follows from the one on equation of state for an ideal gas, where I was looking at the gas laws, Boyle's law, Charles' law, and the pressure law. Please subscribe to the Physics Tips for Cambridge Students YouTube channel and hit the bell notification so that you get alerted of my future videos. And without much further ado, let's get started. Right, in connected gas containers, we have a closed system where gas may flow out from one container to the next. At first, we have the containers with their gases inside, and then the valve is closed, and then afterwards the valve is open, and then the gas can flow from one container to the other. When the temperature rises to the other containers, the total number of moles of the gas in the two remains the same. So we are going to use PV is equal to nRT, making N the subject of the formula. N is equal to PV over RT, which is going to be a constant. So I'm going to illustrate this by an example. So in this example, we have initially bulb A containing 3 cubic meters of an ideal gas at a temperature of 250 kelvins and a pressure of 5.00 times 10 to the power of 4 pascals. And then bulb B contains 7.20 cubic meters and the same gas, that is an ideal gas, at 400 kelvins with a pressure of 2.00 times 10 to the power of 4 pascals. Then says find the final pressure after the connecting tap has been opened and the system has reached equilibrium. Now assume that A is kept at 250 kelvins and B is kept at the same temperature, 400 kelvins. And this question has been taken from Roger Manchester. The first thing to do is to find the total pressure in A and the total pressure in B. So we do so by using our equation. N is equal to PV over RT. P in A, we have said that is this, 5 times 10 to the power of 4. And then V is 3 cubic meters. R is 8.31 and T will be 250 kelvins, that is in bulb A. Then in container B, P is 2 times 10 to the power of 4 pascals, V is 7.20, R is 8.31, and then our T is 400 kelvins. You find that the number of moles in A will be 600 over R, so in terms of R. And then in B is 360 over R, so the total number of moles will be 960 over R. After this valve has been opened, we're going to be having these containers still maintaining their temperature, that is 250 kelvins in A and 400 kelvins in B. To get the final number of moles in A, it's going to be PV over RT, so which is going to be the new P times V is still the same, and then over 250R, and then final moles in B will be the new P times 7.20 over 400R. So the total final number of moles will be those in A plus those in B, which will give 3.00 times 10 to the power of minus 2 P over R. Remember, we said the number of moles does not change, so we're going to have that P over R is equal to the initial number of moles, 960 over R. Then we make P the subject of the formula. That comes to be 3.2 times 10 to the power of 4 pascals. Consider subscribing to the channel. Like, share, and comment as well. Signing out.